time is money. It's also running out, unless possibly it's on your side. Time flies, time is up. We talk about time all the time. But does anybody actually know what it is?
It's 3:30.
That's not what I mean.
Then what do you mean?
What does it mean? That's what we will talk about today. First things first, what is time? Time is what keeps everything from happening at once, as Ray Cummings put it. Funny, but not very useful. If you ask Wikipedia, time is what clocks measure. Which brings up the question, what is a clock? According to Wikipedia, a clock is what measures time. That seems a little circular. Luckily, Albert Einstein gets us out of this conundrum. Yes, this guy again. According to Einstein, time is a dimension. This idea goes back originally to Minkowski, but it was Einstein who used it in his theories of special and general relativity to arrive at testable predictions that have since been confirmed countless times. Time is a dimension, similar to the 3 dimensions of space, but with a very important difference that I'm sure you've noticed. We can stand still in space, but we cannot stand still in time. So time is not the same as space, but that time is a dimension means you can rotate into the time direction, like you can rotate into a direction of space. In space, if you're moving in, say, the forward direction, you can turn 45 degrees and then you will move instead into a direction that's a mixture of forward and sideways. You can do the same with the time and the space direction, and it's not even all that difficult. The only thing you need to do is change your velocity. If you're standing still and then begin to walk, that does not only change your position in space, it also changes which direction you are going in space-time. You are now moving into a direction that is a combination of both time and space. In physics, we call such a change of velocity a boost, and the larger the change of velocity, the larger the angle you turn from time to space. Now, as you all know, the speed of light is an upper limit. This means you cannot turn from moving only through time and standing still in space to moving only in space and not in time. That does not work. Instead, there's a maximal angle you can turn in space-time by speeding up. That maximal angle is by convention usually set to 45 degrees. But that's really just convention. For the physics, it matters only that it's some angle smaller than 90 degrees. The consequence of time being a dimension, as Einstein understood, is that time passes more slowly if you move, relative to the case when you were not moving. This is the time dilation. How do we know this is correct? We can measure it. How do you measure a time dimension? It turns out you can measure the time dimension with, guess what? The things we normally call clocks. The relevant point here is that this definition is no longer circular. We define time as a dimension in a specific theory. Clocks are what we call devices that measure this. How do clocks work? A clock is anything that counts how often a system returns to the same or at least a very similar configuration. For example, if the Earth orbits around the Sun once and returns to almost the same place, we call that a year. Or take a pendulum. If you count how often the pendulum is, say, at one of the turning points, that gives you a measure of time. The reason this works is that once you have a theory for space-time, you can calculate that the thing you call time is related to the recurrences of certain events in a regular way. Then you measure the recurrence of these events to tell the passage of time. But then, what do physicists mean if they say time is not real, as for example Lee Smolin has argued? As I have discussed in a series of earlier videos, we call something real in scientific terms if it is a necessary ingredient of a theory that correctly describes what we observe. Quarks, for example, are real not because we can see them, we cannot, but because they are necessary to correctly describe what particle physicists measure at the Large Hadron Collider. Time, for the same reason, is real because it's a necessary ingredient for Einstein's theory of general relativity to correctly describe observations. However, we know that general relativity is not fundamentally the correct theory. By this I mean that this theory has shortcomings that have so far not been resolved, notably singularities and the incompatibility with quantum theory. For this reason, most physicists, me included, think that general relativity is only an approximation to a better theory called quantum gravity. We don't yet have a theory of quantum gravity, but there is no shortage of speculations about what its properties may be. And one of the properties that it may have is that it does not have time. So this is what physicists mean when they say time is not real. They mean that time may not be an ingredient of the to-be-found theory of quantum gravity, or, if you're even more ambitious, a theory of everything. Time then exists only on an approximate emergent level. Personally, I find it misleading to say that in this case time is not real. It's like claiming that because our theories for the constituents of matter don't contain chairs, chairs are not real. That doesn't make any sense. But leaving aside that it's bad terminology, is it right that time might fundamentally not exist? I have to admit, it's not entirely implausible. That's because one of the major reasons why it's difficult to combine quantum theory with general relativity is that time is a dimension in general relativity. In quantum mechanics, on the other hand, time is not a dimension. It's not even something you can measure. It's not unobservable, as the physicists say. In fact, in quantum mechanics, it is entirely unclear how to answer a seemingly simple question like, what is the probability for the arrival time of a laser signal? Time is treated very differently in these two theories. What might a theory look like in which time is not real? One possibility is that our space-time might be embedded into just space, but it has a boundary where time turns to space. Note how carefully I have avoided saying before it turns to space. Before arguably is a meaningless word if you have no direction of time. It would be more accurate to say that what we usually call the early universe, where we expect a Big Bang, may actually have been outside of space-time, and there might have been only space, no time. Another possibility that physicists have discussed is that deep down the universe and everything in it is a network. What we usually call space-time is merely an approximation to the network in cases when the network is particularly regular. There are actually quite a few approaches that use this idea. The most recent one is Stephen Wolfram's hypergraphs. Finally, I should mention Julian Barber, who has argued that we don't need time to begin with. We do need it in general relativity, which is the currently accepted theory for the universe, but Barber has developed a theory that he claims is at least as good as general relativity and does not need time. Instead, it is a theory only about the relations between configurations of matter in space which contain an order that we normally associate with the passage of time, but really the order in space by itself is already sufficient. Barber's view is certainly unconventional and it may not lead anywhere, but then again, maybe he's onto something. He has just published a new book about his ideas. This video was sponsored by Brilliant, which is a website and app that offers interactive courses on a large variety of topics in science and mathematics. If you want to understand better what space-time is, what boosts are, and how time dilation works, then Brilliant is a great place to start. To get more background on this video's content and to see how the math works, I recommend you look at their course on special relativity. It will teach you all you need to know about Einstein's ideas, Lorentz transformations, and the odd consequences that follow from that. To support this channel and learn more about Brilliant, go to brilliant.org/Sabine and sign up for free. The first 200 subscribers using this link will get 20% off their annual premium subscription. Thanks for your time. See you next week.